Hi, my name is Jane Eva Aurelia. You may call me Jane, and I'm from University of Indonesia. Today, I would like to represent to you my research paper called Hepatitis Classification using support fed machine and random forest. Now, let's jump to our presentation. Hepatitis classification using support fed machine and random forest. What is exactly hepatitis? Hepatitis is an inflammation of the liver. The condition itself can be self-limiting or can change to cirrhosis, fibrosis, and liver cancer. Hepatitis virus are the most common cause of hepatitis in the world, but other infections like Hepatitis and autoimmune disease can also cause hepatitis. There are 5 main hepatitis viruses, such as hepatitis virus types A, B, C, D, and also E. These types are the greatest concern because the burden of illness and death, also the potential for outbreaks and epidemic spread, especially types B and C. Hepatitis A and E usually caused by injection of contamination food and water. Hepatitis B, C, and D usually caused by result of parental contact with infected body fields. The infection may occur with limited or no symptoms, but also may include some symptoms like abdominal pain, dark urine, extreme fatigue, jaundice, nausea, or vomiting. Indonesia itself, because they are a large archipelago, the prevalence of viral infection varies greatly by region of acute hepatitis patients, such as 43% to 68% infected with hepatitis A virus, 6% to 26% with hepatitis B virus, and 50% to 37% infected with non-hepatitis virus A nor B. Non-hepatitis virus A antibodies, or we can call it anti-HAV, were detected in 36% to 100% of 5-year-old children. Hepatitis C virus antibody, or we can call it HCV, was detected in 0.5% to 3.4% of blood donors, 10% to 16% of acute hepatitis, 31% to 74% of liver cirrhosis, and 21% to 41% of hepatocellular carcinoma patients. Now we're going to discuss our research methods. First, support fed machine, or we can call it SVM. SVM is supervised machine learning models that use classification algorithms for 2 groups classification problems. After giving an SVM model sets of level training data for either of 2 categories, we are able to categorize new example. For better understanding, now we're going to take a look at this little illustration of support fed machine. As we can see at our screen, our goal is to make it as wide as possible and keep them separate. For example, we divided the positive area and the negative area. And the function, if we summarize it, it's gonna be like this. In this study, kernel functions are used in SVM. The kernel function resolve problems that are linear in order to be applied to nonlinear problems, especially for algorithm expressed in inner product between 2 vectors. And this all the kernel functions that we use in our research with their parameter. First, linear kernel SVM. Second, polynomial kernel SVM. And second, RBF kernel SVM, or we can call it gradient basis function. Our second method is random forest, or we can call it RF. Random forest is a flexible and easy to use machine learning algorithms that produce A great result will produce most of the time even without a hyperparameter tuning. Because RF simplicity and diversity, random forest also one of the most used algorithms. Random forest also a tree-based ensemble which be a combination of each decision tree depending on a collection of random variables. The digits tree is a flowchart shape like vector. For n-dimensional, the random factor x represents the predator variables, and a random variable y represents the real value response. For better understanding, we're going to take a look at this illustration of random forest. Many is better than one, or we can call it n trees. Picking of tree learners or training subsets via bootstrapping, which the column is going to be m and divided to this. Majority rule are for prediction. There's also OOB. Besides classification, RF also can numerical prediction. To calculate the accuracy, conversion metric is used. And this is the formula for the accuracy with all their own definitioned parameter. Now we're going to take a look in our data and result. First, data. The data used in the study are from hepatitis patient with amount to 113 data with 5 feature person as 90% training data and 10% testing data, with actual amount of 84 major data and 29 minor data. Minor data represent data classes that indicate the presence of inflammation with level 1. While the major data represent data classes that do not indicate inflammation with level 2. There is also a feature of hepatitis datasets that we use in this study. Gender, SGOT, SGPT, anti-HCV, and diagnosis. Second, our result. This research used training data diverse from 10% to 90%. There is going to be two tables that can show the result of the performance of accuracy of the entire method used and also shows the result of the comparison of running time of each method. As you can see, at the table, the best accuracy obtained was 99.55%, which resulted from the SVM model with a Gaussian RBF kernel, followed by linear kernel SVM, random forest, and the lowest level accuracy from the SVM model polynomial kernel. Gaussian RBF has the best accuracy with 10% to 40%, 60%, and also 80% training data. At the second table, Gaussian radial basis kernel gives the best performance with an average running time of 2.3, followed by polynomial kernel SVM, linear kernel SVM, and lastly, random forest. All of the methods are good for classification, leading to hepatitis. The highest accuracy resulted with value 99% are from linear kernel and Gaussian RBF. However, based on accuracy and running time, the best method to classify hepatitis is Gaussian RBF kernel SVM. And this is my conclusion. Predicting the presence of inflammation in the liver of a patient in diagnosis with machine learning can help medical staff to classify hepatitis disease. An early detection can make patients get the right treatment that helps them increase their life and also reduce the risks. In this study, there are 4 methods used. SVM with linear kernel, SVM with polynomial kernel, SVM with Gaussian RBF kernel, and the last one is random forest. The experimental shows that the performance of SVM classifier and random forest method are properly and correctly predict the data. However, based on our results, if we see both of performa and running time, so 4-beta machine with Gaussian RBF kernel is the best one to classify hepatitis data. Hopefully, in the future research, this method can be used with a larger dataset so we can develop to give more better accuracy for predicting or classifying the other diseases. Last but not least, I would like to say thank you for all of your attention, and hopefully this presentation can make you more understanding my research paper that you interest. And hopefully we can meet in some other times. Thank you.